Okay, so today we have Chapter 4, Section 4, Day 2, Graphing the cosine function. The cosine function is very similar to graphing the sine function. It's just where you plot your points is going to be a little bit different. So we still need the amplitude and the period. You get the amplitude from the a value. That's what's in front of your function. My function is cosine. I have one cosine. So that means the amplitude is the absolute value of a, which in this case is 1. So from the x-axis, I'm going to go up 1 and down 1. So we're not using one block because that would be a squished graph and it would not look nice. So we're not doing that. We're setting our value. So it's very important to label all of your axis points on all of these because most of the time they look the same. It just depends on what you've assigned that value to be. So we also need to know the period length. We know it's going to be the fourth quadrant. Each one of these represents a quadrant. Quadrant 1, 2, 3, or 4. In this case, we have 1x, so the b value is 1. And the period length is 2 pi over b. So if it's 2 pi over 1, it is 2 pi, which makes sense for the parent function. So 2 pi, cut that in half, it gives you pi. Cut that in half, it gives you pi over 2. So then to get the third one, you multiply the smallest one times 3. 3 pi over 2. Yesterday I showed you Sahala as a way to remember graphing sine. It was sine is axis high, axis low, axis. Today we're going to go with chala, which is a type of bread, right? You all know that bread? Chala bread? Oh, it's a thing. It's good. Anyway, chala. It's like you know, on the end, you know? I don't say it right, I'm sure, but there you go. And it's C for cosine, and it tells you you're going to go high, axis, low, axis, high. So we go to when x is 0, and we start with on the high point. And then we go to the axis. And then we go low, and then we go to the axis, and then we go to the high again. And it looks like a V whenever you just look at the points. But remember, this is a wave. There's no sharp points on this anywhere. Even at the beginning, you're not starting with going straight down, because if you imagined it being more to the left, it would be up and then curve down. So you do a curve. So there is the cosine graph. It pretty much looks like the sine graph. It's just out of phase by one quadrant. Phase, remember, was horizontal shifts, the phase shift. So if we look at example 3 from yesterday, which I'm going to slide this down so you can see example 3 from yesterday. This is basically what you would have if you, like, okay, if this was the y-axis, that would be the cosine, the purple one, and the sine would be this blue one. So they look, it's the same wave, it's just they're off by one quadrant. Does that make sense? Great. All right. And then one more thing to tie it together with unit circle is let's evaluate the function. Cosine of 0, let's think of the unit circle or the hand trick or however we've learned in the past. The cosine of 0, if we do the hand trick, then you fold in the 0 degree finger and we have 4 fingers above, which represents cosine. So it's the square root of 4.
That's possible. But like, how I can do that?
I don't know. You just bend your pinky.
Like, look at how it's finished. Oh, wait, how do you do that? What the fuck? Ew. Okay, sorry. I'm
just talented, I guess. I don't know.
How do you do that?
No, I can't. There you go.
Wow.
Okay. Cosine of 0. So I had 4 fingers. So it's square root of 4 over 2. Square root of 4 is 2. 2 over 2 is 1. So the cosine of 0 is 1. Cosine of pi over 2. Oh, wait, and then from our graph. So that's the value we get from unit circle or hand trick. Let's look at our graph. If this is cosine of x equals y, cosine of x is 0, what is the y? 1. It's 1. Cosine of pi over 2. Pi over 2 is this one. There's 0 fingers above, so 0 over 2 is 0. If we go when x is pi over 2, what is the y value? Where's the graph? It's on 0. It matches. It's saying the same thing. So the unit circle, this is the graph of the unit circle. So cosine of pi, think of the unit circle all the way around to the left. That's -1. So if we go to pi, when the x value is pi, the y value is -1. Same. Cosine 3 pi over 2, it's at the bottom, so that's 0. Look at the graph. The y value is 0. At 2 pi, the cosine is 1. When x is 2 pi, the y value is 1. So and then it would repeat the next period. Every repeating period is like a coterminal angle.
I know. It's like it's really matching up. 0, -1, 0, 1.
Yeah. And then it just repeats as you go over and over. And it'll click eventually if it doesn't click at this moment.
I don't think it's clicking.
So this is a XY graph version of the unit circle. There you go. You got it.
Well, that's what
See, here's the thing. When you explain it, I know what I'm doing, but then I go into the homework and I don't know what I'm
That's why I recorded for you, so I can walk you through it when you're ready to do your homework. All right, let's look at the vertical dilation and reflection. So we're doing 2 of these in one. So first of all, anytime you see that your function is negative, you should make a note that this is negative, so this is going to reflect over x-axis. So you don't forget to do that at the end, because that's the last thing you're going to do. If I don't make a note, I forget, and I'm like, oh, there it is, and then it's wrong because I didn't reflect it. Then I need to figure out the a value. A here is -3. That helps me with the amplitude, which is the absolute value of -3, which is 3. And then the b value is what's in front of x. I love it when x is 1. It makes whenever the b value is 1 because it makes it nice and easy. B equals 1. So the period is 2 pi over 1, which is 2 pi. Once you have the notes on your function of everything you need, I already set up my x and my y. I go to my y-axis. The amplitude is 3, so that means I need to go up 1, 2, 3, and down 1, 2, 3. The amplitude is like the height in each direction. So 3 and -3. Sorry? Oh, sure. The next, on the x-axis, every single time we're marking the 4 quadrants. So every single time I'm going 2 blocks, quadrant 1, 2 blocks, quadrant 2, 2 blocks, quadrant 3, 2 blocks, quadrant 4. The period length tells me the value I assign to my 4th mark, the end of my quadrant 4. So 2 pi. When the period length is 2 pi, finding the rest of them is easy because you already know the unit circle values at the quadrants. But it's a good idea to practice going through the process of, you have the 4th one, you cut it in half to get you the 2nd one. So 2 pi, half of that would be 1 pi. And then you can cut that one in half. It's pi over 2. And so then you just have to figure out what that third one is. And that means you have 3 of whatever the first one is. So 3 pi over 2 in this case. If you end up with fractions that can be reduced, reduce your fractions. If you have an odd number and you divide it by 2, then you just have like 5. Like if this was 5 pi and I need to divide it by 2, well 5 doesn't divide by 2, so this would just be 5 pi over 2. It would be, cut it in half, you just put it over 2. Okay, so now we're going, since I do have a reflection, I want to sketch without reflecting first and then reflect it. Does that make sense?
Sketch it first and then sketch it.
And then do my final one. So I'm going to do a light sketch without the reflection, just this. And remember I said this is Chala. I'll put that here, C-H-A-L-A-H. So I'm going to start high and then go to the axis. And then I go low. Then I go to the axis. And then I go high again. And I'm just going to do some dash lines, really lightly sketch what it would look like if it was not reflected. But this one does need to be reflected. So then I go back, and all of my high points, like this started high, I need to go low. So I'll put a point there. To reflect over the x-axis, that's 3 spaces away from x, so I go 3 spaces in the other direction. When I reflect over x, this point is there's 0 spaces to get to x, so it's still 0. It stays there. This one is 3 below x, the x-axis, so I need to go 3 above the x-axis. Back to the axis. This one's high, so it has to reflect to low. And that will give me my final graph. So there it's been reflected. Are we good with that?
Yes.
Thank you. All right, so example 3 is a period change. Period change can be tricky. But we just start the same way we start all of them. You need, find the a value. It's whatever's in front of the function. So a equals 1, which tells me the amplitude is 1. And then I look for the b value. Well, there's not a number in front of x. X is inside a fraction. First of all, I don't like that. I want x to not be in a fraction, which that's not hard, right? Because that's x over 2. It would be 1/2 x. So if I just want to pull the number out front, I could rewrite this as cosine 1/2 x. And now I can clearly see the b value. It's right there. B equals 1/2. And you use the b value to determine the length of the period. So the period is 2 pi over b. So this is 2 pi over 1/2. So we have something divided by a fraction. We do not want to divide by a fraction. That is gross. You don't want a fraction in a fraction. So to get rid of that, you take the denominator and you multiply it by its reciprocal. So if I want to get this fraction out of there, I need to multiply it by its reciprocal. So 2 over 1. And now my 2's will reduce, so I just have 1 in the denominator now. But anytime I can't just change one part of a fraction. If I'm going to change the fraction, I have to change both the top and the bottom, right? So 2 over 1 is the same as 2. So I could say times 2 on the top. Oh, so then the denominator is just 1, so I have 2 pi times 2 is 4 pi. So my period length is going to be 4 pi. So if you ever have a fraction inside a fraction, Take the denominator and multiply it by its reciprocal. Okay, so my amplitude is 1. Up 1, down 1. 1, negative 1. This, 2 pi over b, that's the formula to find the period. 2 pi over b. b is half, so 2 pi over half. All right. Yes, you should absolutely ask questions if you have them. 3 and 4. So I marked 4 lines on the x-axis because there are 4 quadrants. That fourth one I know has a length. The length to the fourth one is 4 pi. So then halfway, yes, it's 2 pi. Well then, what, Valerie, what's half of that one? Okay. No, half of 2 pi is pi. Well, you said that first and you said no. Yeah. So then what's the third one? It's 3 of these. So it's 3 pi. Yeah. So I have all of my points. All I have to do now is sketch it. So I'm going to say for cosine, I start high. Then I go to the axis. Then I go low. Then I go to the axis again. And then I end up high again. And make it curvy. Because it's a wave. No straight lines or sharp edges in waves. So it's very important you label everything because that looks, really it looks the same as the parent function if we look at just the graph. The only difference is that my labeling on the x-axis is different. So unless there's a phase shift or a vertical shift or a reflection, they're pretty much all going to look the same. All right, so the next example is a phase shift. A phase shift, 2. A phase shift is just a fancy way of saying a horizontal shift. It's a phase shift. Okay. All of these we start the same way. Start by looking for the A value and the B value. A value on this one's super easy because there's nothing in front of cosine, so that means it's a 1, so A equals 1. So the amplitude is the absolute value of 1, which is 1. When we go to find the B value, though, when there's a phase shift, we have x plus or minus something inside the parentheses, you can't just take the half because you have to factor it to the outside of the parentheses. The B value is always outside of the parentheses. So first, we need to factor out, we know from the last problem x over 2 is half x. So we want to divide by half, and if we have to divide both of them by half. So that we could bring the 1/2 outside of the parentheses. So on the first term, we have half divided by half. Anything divided by itself is just 1, so that's great. That cancels. We have now cosine of 1/2 parentheses x plus, but then we have that. Pi over 4 divided by half. So I'm going to go over to the side with that. And I'm going to write it as, remember I said pi, well, I'll write the whole thing. Pi over 4 divided by half. We have a fraction divided by a fraction. I don't like a fraction divided by a fraction. That's pretty, like I said earlier, it's pretty gross. So I want to get rid of, I want to multiply by the reciprocal of the denominator. Flip it. If I multiply by 2 over 1 on top and bottom, on the bottom it cancels, which is why I'm doing it. That's the whole point. So now I have 2 pi over 4. 2 pi over 4. Well, 2 over 4, that's half. So this is pi over 2. And that, so it's going to be x plus pi over 2. Now I have my function written in standard transformation form. So if there's a value with the x, and there is a plus or minus inside parentheses with it, you have to factor that value outside in front of the parentheses. So you divide both of them by whatever it is. If it's a fraction, you have fraction divided by fraction, multiply by the reciprocal. And there we go. So now I can see the b value. So b equals half. So the period length is 2 pi over b. So I have 2 pi over 1/2, which we did that in the last problem also. Again, we multiply by the reciprocal, so that's 4 pi. And this one also has another transformation. Right here, now remember that in the standard form it's x minus c. This is plus. So that means this is x minus negative pi over 2. So the c value is negative pi over 2, which tells me I have a phase shift to the left. I'm going to abbreviate phase shift with PS because I already have it up here. So this is a PS left by pi over 2 spaces, units. All right, so then I want to graph this. When I graph and I have a phase shift, I'm going to do a sketch of it without the phase shift and then shift it. I find that to be the best way to do it. But first I need to set it up. My amplitude was 1, x-axis, y-axis, 1, up 1 and down 1. Mark my 4 quadrants. I know the length of the 4th quadrant is 4 pi. The period is 4 pi. So I can label the other 3. 4 pi, cut it in half as 2 pi. Cut that in half as pi. So 3 of those is 3 pi. Then I'm going to do a sketch by going high axis, low axis, high. So that's what this graph would look like if I did not have a phase shift, but I do have a phase shift. I'm going to shift it to the left, pi over 2 units. I don't have that unit marked on my x-axis. So let me look at the smallest one I do have. The smallest one I have is pi. But if I only want to move pi over 2, then that's half the distance to pi. So that means this space would be pi over 2. So then the first one, when x is 0, I need to move that to the left by pi over 2 also. So I need to label that one as negative pi over 2. So I take this dot, move it over here. take this point at pi and move it over here to pi over 2. And each one means I have an in-between mark. Take the 2 pi, move it over. Another one here. Another one in between these two, and move that one over. So you're just moving each point over that amount, and then you can draw your final, graph your final function. Phase shift left by pi over 2. It all depends on the scale that you set at the beginning. Okay, so then one more. A minute. Okay. All right, the last one is a vertical shift. We start this the same as we start all the others. You need A, you need B. But if we look at this one, there's no parentheses, but there's a +1. So it kind of sounds like an obvious thing whenever I say it, that if there's not parentheses around the 1, that it's not in parentheses. When I write a trig function on my paper, I always like to put parentheses on it so I don't question later whether or not this is x plus 1 inside parentheses or the 1 is on the outside. So but in the book, they never print the unnecessary parentheses. I like the unnecessary parentheses. So I want to group that. Since the 1 is not in parentheses, I cannot assume that it isn't meant to be inside. But to me, I like that. It looks a lot better. I won't get confused if I look back at it later. Okay, so then my A value is 2. Absolute value of 2 is 2, so the amplitude is 2. This makes the B value really easy because it's 1x, and that +1 is on the outside, so I don't have to do anything to find that the B value equals 1. When the B value is 1, it's the standard period 2 pi. And then my new transformation here is a D value that equals 1. Vertical transformations are just as they look. Positive shifts up, negative shift down. So this is a shift up. 1 unit. All right, so my amplitude is 2. I'm going to go up 1, 2, down 1, 2. I'm going to label those. I need to label my x-axis with my 4 quadrants. 1, 2, 3, 4. The 4th quadrant is at 2 pi. So that means I have pi over 2, 3 pi over 2. All right, so on this one, since there's not a lot happening except for the vertical shift, if I had other things going on, then I would do a light sketch with that stuff. But for the vertical shift, you're shifting the midline. On all of them that we've done that have not had vertical shifts, the midline is the x-axis, and the amplitude is based around the midline. But if we're going to shift, we're shifting the midline. So the x-axis is the original midline, but we need to shift up. So our new midline is 1 unit up from there. So this is the new midline. We can unofficially call it an axis. It's not actually an axis because those are very specific things, but the new midline / axis. So if we're shifting the midline, the amplitude needs to match. The amplitude is still 2, So we still have to go 2 spaces up from the midline. So I need to add another mark above 2. It needs to be at 3. And I like, when I do my vertical shifts, I find putting the new lines on there very helpful. The new midline and your new dashed lines. So your new upper boundary, and we need a lower boundary. If we were at negative from here, we also need to go down 2 units. So 1, 2 would be the new one. The new lower boundary also shifted up 1. And then sketch, C-H-A-L-A-H. Cosine goes high, my new high boundary, and then back to my new axis, and then my new lower, new axis, new high. And there you go. Homework, page 264. I'm not sure. Maybe. Number 3, number 7, 15, 18. Those are the straight graphing cosine. You have 4 of those. And 31 and 33, which are super fun problems. Where you like that, huh? Yeah, it's going to give you a graph, and you're going to write a function based on the graph for those last 2.